This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. On this video, we're going to solve the following word problem using a systems of equations with two variables. At a game, 212 cups of coffee were sold and $489 was collected. If small coffees sold for $2 each and large coffees sold for $3 each, how many of each size was sold? So this lends itself to a system of equations because there are two things we don't know. We don't know how many large coffees are sold, and we don't know how many small coffees are sold. So here's the problem again. Now there's different ways you can define your variables. One, you could simply say let x be the number of large coffees sold and y be the number of, I forgot what I just said, the opposite, either large or small. I like to put the information in a chart, so I'm going to do it that way. So this just makes it easier for me. It's personal preference. So this is like what kind of cup, small or large. So first it talks about the small, so I'm just going to be the small and the large. And I'm going to write how much it is for a unit, and that means, in other words, 1 cup. So if you want to put 1 cup instead of unit, that's all right. And since everything seems to be in dollars, I'm going to keep everything in dollars instead of writing everything in terms of cents. If I wanted to write everything in cents, I would think of $2 is 200. But in dollars, a small coffee goes for $2, so 1 cup of coffee is $2, and 1 large cup of coffee is $3. Now, I don't know how many of each. I'm going to say, okay, number stands for how many are sold. And this is where we define our variables, right here in this column. I don't know either of them, so I'm going to let one of them be x, the other one be y. And notice that altogether, 212 cups of coffee are sold, so I'm just going to write a little column down here for the totals. The total number of coffees that were sold is 212. This is going to lend me to an equation, x plus y equals 212, which I'm going to write under here right now. That is going to give us one of the equations we want. Now, what about the total amount collected from each of these coffees sold? So I'm just going to put the totals over here. Total collected. So if you sold x small cups of coffee, each one costing $2, you just multiplied 2 times x. So that's the amount of money collected. So maybe I should say total dollars or total dollars collected. So we're clear. We're talking about money in this column. And for the large cups of coffee, each cup is $3. I sold y cups, so we multiplied. That'll be 3y. And we know that amount added up to a total of $489. That's its total. Okay, so the total I collected from selling the small cups plus the total I collected from the large cups should give me my total amount collected overall. And that gives us our second equation, 2x plus 3y equals 489. So one is talking about just the total number of cups, and one is talking about the revenue, how much money we're collecting. So this is our system of equations. We have 2 unknowns or 2 variables, and we've got 2 equations. So you can either use the substitution method or the addition elimination method. I'm going to use the addition elimination method because if you could write this right under this right now, x plus y equals 212, but instead I'm going to say what would I multiply this by so I could either get the x's to be opposite, so they'll add to 0, or the y's. And I like multiplying by smaller numbers. So I'm going to take this equation and multiply it by -2. And I'm going to put it down here so you'll see my other equation. So -2 times x will be a -2x. -2 times y will be a -2y. Don't forget to multiply the other side of the equation by -2 as well. -2 times 212 will be -424. Because remember, whatever you multiply one side of the equation by, you also have to multiply the other side of the equation by. So let's see. Now, this is very convenient, because if I add up here, the x's cancel. 3y minus 2y is y. And subtracting over here, that looks like it's 65. So if I did it correctly, it looks like y, which stands for what? Y is the number of large copies sold. It's going to be 65. Now, for checking it, here's another thing you can do. You can actually make this chart again, but actually fill in the real numbers that are actually there now. So I've got small and large. I know for 1 cup of coffee, which I'm going to just still call it unit, it's $2 and $3, right? But I actually now know what y is. So instead of writing y, I'm going to write 65. And I know the total was 212 cups, right? So could you figure out the number of small cups by thinking about that? Well, if 65 are large, you would subtract 65 from 212. And that would give you 147 cups of coffee. So let's put the total money collected over here and see if we would end up with a revenue of $489. That's what we're hoping. This is what we need to check. So let's see. If you sold 147 cups of coffee at $2 each, you're going to have to do 147 times 2, and that gives $294. And then I'm selling 65 cups of the large coffee at $3 each. I'm going to put the unit amount. This is just how much it is for each cup. So I'm going to have to do 65 times 3, and that gives me $195. So the question is 295 plus, I'm sorry, 294. To copy it, right? $294, that's the revenue from the small coffees, plus 195 the same as 489. And you could do that arithmetic in your head. 294 plus 195 does equal $489. And I say I have 212 cups of coffee sold, so it looks like I do have the right answer here. So we go back up here a little. So how many of each size? So we ended up with 147 small cups were sold. Oops. And we had 65 large cups. And remember where I got that. Just you can't see it. Remember, it was right here. There was the 147 and the 65. And we checked it. So all is well, and there we go. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.